The sheet that I just handed you is a copy of rules that go along with giving oxidation numbers to certain elements in a compound. You watched the video yesterday, and the rules that I gave you there are the ones, how they correspond to my PowerPoint presentation. So these are going to be in the order, whereas the ones you took yesterday might not necessarily be in the order that I'm doing those today. So we're going to talk about these oxidation numbers, but let's first discuss once again some learning targets and some success criteria. Well, obviously, we haven't changed anything with our learning target. We're still on nomenclature, so our learning target is still going to be that we need to be able to state the significance of a chemical formula. So we need to be able to have that name of the formula and write that chemical formula. And also, going the other way, the yin to the yang, using the chemical formula to write the name of a chemical compound. So our learning targets are being able to name compounds and to write formulas given the name. Well, today's success criteria is that I can state the oxidation numbers of compounds. We've been dealing with oxidation numbers, and these oxidation numbers are on our periodic table. How we've been using them is to determine if something was multivalent or not, meaning we needed to see if a metal needed a Roman numeral. That's how we've been using them. Ladies and gentlemen, we are going to expand that. We are going to use oxidation numbers to help us name binary molecular compounds using the IUPAC system. So, let's go ahead and just get into the rules. The oxidation number for an atom in its elemental form is always 0. So I have diatomic bromine here. Okay, I have diatomic bromine here. It's by itself. Rule number 1 states that anytime we have something by itself, its oxidation number is 0. So how I write these is I put a little line as so, and I actually just write the number above them. The reason I put that little line in there is when we get to dealing with polyatomics and we get to dealing with compounds that have multiple elements in there, it gets a little crowded. So I like that little line that points you right to what element you are talking about. So in this case, if we have an oxidation number of an element, it is going to be 0. Now this is diatomic bromine. I think one of the examples I have on your paper is, what if it's S8? What if there are 8 of those? Does it matter? No, it's still elemental. That's still the element, so that's going to be an oxidation number of 0 also. Rule number 2 states the more electronegative element in a binary molecular compound is assigned the number equal to the negative charge it would have as an anion. So we're going to need our periodic table, so take out your periodic table if it's not already out. We've got to determine which one of these elements is the more electronegative. You should already have a pretty good idea. If you're going to take a guess, what are you going to guess? Chlorine, right? Because we know that fluorine is our most electronegative. So we're going to guess chlorine. We check the electronegativities, and as I look on my periodic table, I find the electronegativity of chlorine is 3.16. Carbon is 2.55. So chlorine is indeed my more electronegative element. Now, what charge would chlorine be as an anion? Meaning if chlorine was going to be an ion, what would its charge be? -1. Excellent. So, I'm going to draw my line to chlorine here. Chlorine is -1. Now, how am I going to determine what the charge of carbon is? Well, when we have these oxidation numbers, we're going to talk somewhere, and maybe I have my rules a little out of order, okay? But somewhere on the sheet, it's going to say that the sum of all the oxidation numbers in a neutral compound is 0. I think that's rule number 9. So this compound is neutral, so the sum of the oxidation numbers have to equal 0. I know that chlorine has a -1 oxidation number. How many chlorines do I have? I have 4 of them. So my total negative is going to be 4. What makes this statement true? A +4. How many carbons do I have? I only have 1. So my oxidation number for carbon is going to be +4. You've been doing that to try to figure out Roman numerals for metals already. Now, let's look at the periodic table. Okay? Look at your periodic table and find carbon. Can carbon take a +4 oxidation number? Yeah, it says it on there. Now, the point I want to get with that is I don't want you to be too concerned if an element that you have on your periodic table does not say that it could take that oxidation number. All right? Let's say for this we calculated it to be 3. Does carbon take a +3 on there? No. But don't worry about that. Okay? Don't worry about that. I've seen some oxidation numbers when I've done redox reactions that were 2.5. Okay? So those oxidation numbers could get into halves and quarters and stuff like that. So don't be worried if the value is not on the periodic table. When you do your math here, make it equal to 0 and we'll roll with it. Rule number 3 states that the oxidation number of a monoatomic ion is equal to the charge of the monoatomic ion. This is really easy because I see manganese right there. It gives me a charge, so I know that that manganese is going to be 6+. And I know that that sulfur is going to be 2- because it's telling me right in the charge what the oxidation number is. So, is it different being in the elemental form as opposed to being an ion? Yes, it is. Yes, it is different. So don't confuse rule number 1 with rule number 3. Rule number 4 states that the oxidation number of all group 1A metals is equal to +1 unless they are elemental, unless it's rule number 1. So anytime I have a compound that has a group 1 metal, it's going to be +1. Let me ask you this, ladies and gentlemen. Is hydrogen a group 1 metal? It is not. Why, Peyton? Okay. It fits in better where? Group 18 it can fit in. Let me ask you this. Is hydrogen even a metal? No, it is not. Hydrogen is not a metal. So, could hydrogen be +1? Yes. I'm not saying that. Okay? I'm not saying that hydrogen couldn't be +1, but what I'm saying is hydrogen is not a group 1A metal. So it's not a group 1 metal. Rule number 5 states that the oxidation number of all group 2A metals are +2. So if I have a compound that has any one of the group 2 metals, beryllium, magnesium, calcium, strontium, barium, radium, those are all going to take oxidation numbers of +2. Rule number 6 is dealing with hydrogen. Hydrogen has 2 possible oxidation numbers. And those 2 numbers depend on what it is bonded with. When bonded to a non-metal, hydrogen is going to take a +1. When bonded to a metal, hydrogen is going to take a -1. I would say the majority of the time, and we're talking over 90%, of the time, you're going to see hydrogen taking a +1. Okay? So I look at this right here. I have water. Let's follow some rules. Okay, let's follow some rules. First of all, if we would go by the electronegativity rule, oxygen is more electronegative than hydrogen, correct? So that would tell me, based on rule number 2, that oxygen here would take a -2 charge. Now, if that is -2, I know that the compound has to equal 0. So -2 is the negative, +2 has got to be the positive. How many hydrogens do I have, though? I have 2 of them. So each one has to be +1. Okay? So even following our other rules, that hydrogen would work out to be a +1. Now let's look over here. Let's look at the other one, strontium hydride. Okay? Definitely when we see hydrogen on the anion side of an element, it should ring a bell. Usually we're going to see hydrogen first, like we do right here. Now we have hydrogen here on the anion side. So that should set off a little alarm in my mind saying it's something different. Now, if I would follow my rules, I know strontium, I just said rule number 5 was talking about the group 2A metals. I know strontium is a group 2A metal, so it's going to take a +2 oxidation number. So in order for my equation to be correct, I'm going to have this be a -2. So +2 minus 2 equals 0. I have 2 hydrogens, so each hydrogen will take the oxidation state of a -1. That's exactly what that rule states right there. So we can just believe the rule and say, okay, if hydrogen's bonded with a metal, it's going to be -1. If hydrogen's bonded with a nonmetal, it's going to be +1. Rule number 7. Rule number 7 tells us that oxygen has 2 possible oxidation numbers, a -1 and a -2. Well, how do we know? Well, Oxygen is -1 when it is a peroxide. And as I told you, peroxides, we've discussed these before. Peroxides are pretty uncommon. The most common ones I've seen are the very first 3 elements on group 1. Hydrogen peroxide, lithium peroxide, sodium peroxide. Those are the ones that I see the most. And you're going to know it's a peroxide because if I look at this, wouldn't you think that those numbers right there, those 2's, should reduce? You would think that, but they do not. Why do they not? Because this is a peroxide. So when I see this peroxide, I know that this oxygen is a -1 because it is a peroxide. There are 2 of them, so that's a total -2 charge. So to fill out my equation, this has to be +2. That has to be +2. So sodium has to be +1, which follows along with rule number 4, which states that the oxidation number of a group 1A metal is +1. So once again, you could use, your starting point could be different, okay? You could start with that alkali metal and say that was +1, or you could start with the peroxide and say that was -1. Let's look at the other one, Fe2O3, okay? This is the most common you're going to see with oxygen. So I see that oxygen, I'm going to say, okay, that oxygen is going to be a -2. Now, we're going to use that to determine what my oxidation number for iron is. Because if you remember from that lab that you just got back today, iron is multivalent. Iron can take a few different oxidation numbers. So we need to calculate it. I know the whole thing has to be equal to 0. I know oxygen is -2, and there are 3 of them. So my total minus charge is -6. So in order to make this equation correct, I have to have +6. +6 minus 6 equals 0. How many irons do I have? 2 irons. So each iron must have an oxidation number of +3. Ladies and gentlemen, you've been doing that, haven't you? Because you would have named this iron 3 oxide, wouldn't you? You would have had that Roman numeral 3. So you've already been doing this for this metal here, this iron 3 oxide. Rule number 8. Rule number 8 states that the oxidation number of fluorine is always -1. Now that makes sense because if you go back to rule number 2, rule number 2 said that the more electronegative element takes the charge of its anion, right? Well, isn't fluorine the most electronegative element we have? So fluorine is going to take the charge of its anion, always. And that anion is -1. So fluorine will always have a -1 value. Rule number 9 states that the sum of the oxidation numbers of all atoms or ions in a neutral compound is 0. And number 10 states that the sum of the oxidation numbers of all atoms in a polyatomic ion is equal to the charge of the polyatomic ion. Now, what does that mean? Well, we've been setting everything down here at the bottom equal to 0. If we have a polyatomic ion, we have to set it equal to the charge of that ion. So in this instance, I'm going to set this equal to -3 because I know that this is a -3 charge. So, when I follow my rules, where do I start with this one? I am starting with oxygen. In this instance, is oxygen a peroxide? It is not. So what is my charge of oxygen going to be? -2. I have 6 oxygen, or 3 oxygens, so my total minus charge is going to be 6. What completes my equation? Okay? What completes my equation? +3, right? So, as I'm looking at this, I only have 1 phosphorus, right? So, in that case, phosphorus is going to be +3, and oxygen is going to be -2. Any questions about those rules? All right, now, we're going to work a couple of these using our rules for oxidation numbers. So, as I am peeking right here, I see that I have a polyatomic ion I'm going to start with. So right here, I'm going to start with the polyatomic ion sulfate. Okay, and my board obviously is not working. So, maybe that's magic, I don't know. Okay. Now I look at my sulfur right here, my sulfate ion. Okay. I'm going to work oxygen first because I have a rule for oxygen. But I know that based on rule number 10, the sum of oxidation numbers of all atoms in a polyatomic ion equal the charge. So I'm going to put that equal to -2. I know that oxygen is not a peroxide, so oxygen's going to be -2 there. I have 4 oxygens, so my total charge on oxygen is going to be -8. In order to complete that equation, I need to have a +6. So sulfur in this instance is +6. Now, my next two, the one in the middle, nitrogen dioxide compared to nitrogen monoxide. Just going to show you a little bit here of the differences, even when we have the same elements. Okay? I look at nitrogen dioxide here. I'm going to start once again with oxygen. Is oxygen here a peroxide? Okay? Is oxygen here a peroxide? No, it is not. It is not with an alkali metal. So, oxygen's going to be a -2. The whole thing has to equal 0, so my total minus charge is -4. That means my total plus charge has got to be +4 for that nitrogen. Now let's look at the other one. Once again, oxygen's a -2. It's not a peroxide. This time I only have 1 oxygen, so it's -2. So my nitrogen must be +2. Must be +2. Okay? Now, what I want you to do, folks, is we've already done this one, so don't worry about that one. I want you to answer. We've got about 2 minutes until break. I want you to answer the 2 on the outside here, and then we are going to talk about those after we take break. Okay, ladies and gentlemen, let's look at these 2 that I have up here. I'm going to do the one on the left-hand side first, and I'm going to show you how I would come after doing the oxidation numbers on here. First of all, I'm going to start with what I know. I know that oxygen right here is not a peroxide. So I know that oxygen is a -2. I know that potassium is an alkali earth metal, a group 1 element. So, rule number 4 said that group 1 elements take a +1. So, how am I going to figure out phosphorus? Well, I'm going to set everything equal to 0. I know that oxygen is going to give me a -8 because there are 2 of them, or excuse me, there are 4 of them. Each one is a -2. I know that potassium is a +1 and that there are 3 of them, so it's going to give me a +3. So what makes that equation correct? +3 plus 5 minus 8 equals 0. I only have 1 phosphorus, so that tells me that that phosphorus takes a +5. Questions on how I did that? Now, this second one here is a little bit more challenging. All right, a little bit more challenging. I have 2 polyatomic ions here. All right, I have ammonia and I have sulfite. So if I were naming that, that would just be it. Ammonia sulfite, ammonium sulfite. I'm sorry, ammonium, not ammonia. Ammonium sulfite. Now, how am I going to tackle this particular one? The way I do these is I split them up and I act like they're individuals. What do I mean by that? I know that ammonium has a 1+ charge, right? I can look on my ion sheet. Ammonium is 1+. So I can do ammonium by itself and say, all right, everything's got to equal +1. I know hydrogen right there is a +1 because hydrogen is not with a metal, so it takes a +1. So that gives me a +4. That must mean that this nitrogen has to be -3. So I've done nitrogen and hydrogen as ammonia right there. So I'm going to put here a +1, here a -3. Now, I can do the same exact thing for the sulfite because I know that sulfite, SO3, is a 2- charge. How do I know that? Once again, my ion sheet. I look at oxygen. Okay? I know this whole thing has to equal -2. I look at oxygen. Oxygen's not a peroxide, so it's a -2. -2 times 3 is -6. What's going to give me a correct equation there? It's going to be a +4. +4 minus 6 gives me a -2. So that's going to be a +4. So as I go into here, I put a +4. I put a -2. Now, on this particular one, I could do a little check. I could do a little check because as I'm doing this, I know that this entire thing has to equal 0, right? So if I do my check, -2 times 3 is -6, +4 for what I have for sulfur, okay? Now, here's the kind of funky bunch because of those parentheses, okay? Because those parentheses double everything. So I look at that and I say, okay, 4 +4 times 2 is +8. -3 times 2 is -6. So if I go through there and I get my minuses, I can see 6 and 6, -6 and -6 is -12. What is +8 and +4? +12. 12 and 12 equals 0, right? +12 and -12. So I did a little check there. Yes, that is indeed correct.